In the cloud, fast is pretty easy, right? You can always throw more money at a problem to make it go faster. But efficiently fast? Well, that's a whole different ballgame. So today, we're going to dive into performance efficiency, which is really the art of building systems that aren't just powerful, but also smart and, cost-effective.
Okay, so let's get right into it. Moving to the cloud gives you access to an unbelievable amount of power, but it's not some magic wand for performance. If you make the wrong architectural choices, you can end up with a system that's slow, super frustrating for your users, and surprisingly expensive. So the real question isn't just, is it fast? It's, is it efficiently fast? Are you actually using the right resources in the right way at the right time?
So, to navigate all this complexity, you really need a blueprint. And that's exactly where frameworks like the AWS Well Architected Framework come in. We're going to focus on one of its most important parts, the performance efficiency pillar. Think of it as our guide for building systems that are, again, not just powerful, but really, really intelligent.
Let's break this definition down a bit. Notice it's not just about raw speed. The two key phrases here are use computing resources efficiently and maintain that efficiency as demand changes and technologies evolve. And that second part is huge. It tells us that performance isn't some static goal you hit once. Nope, it's a moving target. It's all about being lean, adaptable, and ready for the future, not just being fast today. So, how do we actually do this? The best way to think about it is as a continuous loop, a cycle, with three pretty simple steps. First, you select the right foundation for whatever you're building. Then you constantly monitor how it's performing out in the real world. And finally, you take all that data and you use it to evolve your architecture over time. So let's break down each one of these. Everything, and I mean everything, starts with the choices you make on day one. This select phase is all about laying a super solid foundation. Because trust me, getting this right from the beginning saves you a world of headaches down the road. Before you even start thinking about a specific server or a database, you've got to make a huge decision: your service model. This is a foundational choice that really dictates how much control you're going to have versus how much the cloud provider is going to manage for you. And these aren't just random categories. They come from standards bodies like NIST, the U.S. National Institute of Standards and Technology. Okay, so you can see the trade-offs really clearly here. With infrastructure as a service, or IaaS, you get the most control. You're managing everything from the operating system on up. Then, all the way on the other end, you've got software as a service, or SaaS, where the provider handles pretty much the whole shebang. And sitting right there in the middle is platform as a service, PaaS, which gives you a managed platform to build on top of. Choosing the right one? It completely depends on your team's skills and what your application actually needs. All right, so once you've picked your service model, you've got to get more specific. You start selecting the individual components, and the name of the game here is using the right tool for the job. For compute, you match it to the workload. Maybe you use serverless functions like AWS Lambda for those event-driven tasks that just pop up, do their thing, and go away. Or you use virtual instances like EC2 for applications that are always on. For storage, you align it with how your data is being used, like using object storage, S3 for example, for backups and media. And for databases, you pick one based on the shape of your data, like a classic relational database for transactional stuff. Every single one of these choices is a critical performance decision. Okay, so you've made your initial selections. Awesome. But you are not done. Not even close. Performance efficiency isn't a set it and forget it kind of thing. It's a continuous loop of monitoring what's actually happening and then evolving your architecture in response. And this, right here, is where the real magic happens. You watch, you learn, and you improve. This dynamic relationship between monitoring and evolving, that's what keeps your system efficient and healthy over its entire life. So what does monitoring actually mean? Well, it's way more than just staring at some CPU charts. It starts with defining your key performance indicators, or KPIs, that actually tie back to your business goals. So for an e-commerce site, a huge KPI might be page load time, because we know for a fact that every 100-millisecond delay can drop sales. Then you collect telemetry, which is basically all the data your system gives off, like metrics, logs, traces, that tells you exactly what's going on inside. You can proactively hunt for weak spots with load testing, and, this is crucial, you measure the actual user experience to see the real-world impact of your system's performance. Now you've got all this great data from monitoring, and you can start to evolve. And this quote from the AWS framework, this is the golden rule. You don't make massive, terrifying, risky changes. Instead, you make frequent, small, and, most importantly,
reversible adjustments. This approach limits the blast radius if something goes wrong, and it lets you ship improvements way more often.
So here's the bottom line. Evolution isn't about guesswork. It's about taking that rich data you gathered while monitoring and using it to make smart, informed scientific improvements. Did a load test show a bottleneck? The data will point you to the fix. Are your users in Europe seeing a bit of lag? Your telemetry will guide you to the right solution. It's literally a data-driven conversation you're having with your system.
So we've covered the what and the how, but let's talk for a minute about the why. I mean, why should anyone, from an engineer all the way up to a CEO, care so much about performance efficiency? Well, because the benefits go way, way beyond just technical bragging rights. First and foremost, a performance system is just a joy to use. Pages that just snap open, high availability, reliability, all of that translates directly into happy, engaged customers. A slow or buggy experience is probably the fastest way to lose a user, and a super efficient architecture is your best defense against that. Oh yeah, this is a big one. Efficiency is the enemy of waste, plain and simple. When you use your resources efficiently, you're not paying for idle servers or databases that are way too big for their job. You are perfectly matching your supply of resources to the actual demand. And that means your cloud bill directly reflects the value you're providing, with no fat, no excess. And this is becoming more and more important to everyone. An efficient architecture is a green architecture, using fewer compute resources, optimizing how your data moves around. It all means you're consuming less energy. And that reduces the environmental footprint of your operations, which is a win for the planet and honestly, a win for your brand. So I'll leave you with this one final thought. Look, it's easy to chase speed by just throwing more resources and more money at a problem. But true excellence, that comes from architecting for efficiency. See, efficiency delivers that speed you want as a byproduct, but it also brings cost savings, a much better user experience, and sustainability. It's the smarter, more strategic path to building incredible systems in the cloud.